sir.
So let us discuss. We are discussing clamper circuits. So we have seen how positive and negative clampers circuit works. Okay. Now we'll see some biased clampers. Biased clampers means again these are positive and negative clampers. So let me discuss first positive clamper. So Vs is again Vp sine omega t here. Okay. And positive clamper means my diode should be current should flow in the upward direction. And now I say I am putting a battery here. Say I'm putting a reference battery here, VR or B, whatever you say. Okay. And here my capacitor is there. So how much now shifting will happen? Okay. How does my clamping works? So for these kind of circuits, and of course here you have RL, and again you are measuring the voltage here. So I told you if if it is happening, if this is the AC source, okay. If current flows in the positive cycle, this diode will be reverse bias. Okay, reverse bias. Of course, the voltage should be greater than this one, greater than this VR. After that, this diode will be in reverse bias. But positive cycle, because most of the current passes through the resistor, voltage drop happens here only. So the capacitor does not charge fully. The capacitor charges only in the direction of this side. We have at this side because this is the opposite sides. So now let us assuming that charging happens in this direction. Okay. So when this diode is forward bias, sorry, we are doing wrongly because I want the shifting this side. So okay, current will flow in this direction. So when this is a negative and this is a positive current flow, this is a positive and is a negative current flows like this. And that condition, this diode become forward bias. It is already forward bias and you apply more voltage, become forward bias. And now what happens? This capacitor charges. So earlier this battery was not there, so we are saying the capacitor charges up to the peak value, but now this battery is there, so we have to find what is VC. Okay. Earlier case, we can directly say this whole magnetic charges VP is coming here because here no battery is there. So now if I write, because this is current is flowing like this, so I can write say minus Vs minus VR, okay, minus VR, and then this plus VC equals to 0. So VC become Vs plus VR, and this is changing from up to peak value. So I will take the peak value of this one. So VC will be VP plus V gamma, VR, VC. So the voltage here will be now capacitor voltage VC will be here VP plus VR. This is the difference when there was no battery and now battery is there. So this capacitor become this V plus VR. Okay. Now we see how does it works. So now if I write that this is now once this becomes charge up to P plus VR, this diode now this voltage is always greater than sum of these two because this maximum gain PP and this VR. This voltage is always against of these two batteries and this make diode open circuit. So this will be out of the picture and now only you can see what is V naught is coming and now I can remove this one because this goes plus minus both sides. This is a fully charged and it will remain charged because the RC constant is very high. I told you it will not discharge now for coming time. So this is the stationary. This is what you can say equilibrium state or stable state, stable condition of the circuit. Now you can write, say, this is minus Vs, okay, minus Vp plus V gamma and plus V naught equals to 0. So V naught will be what? V naught will be now Vs plus Vp plus V gamma. Sum of all the things. Okay. This is the my V output. Now let us draw the circuit and see how the clamping happens. So draw the waveform and tell me how clamping works. So I'm writing this output here. V naught equals to Vs plus Vp plus battery voltage. Okay. And let us plot the curve now. This is my Vs, V input. I'm plotting a little bit broad, so points should be drawn in this way. Okay. And now, okay, this is your Vs. Now I want V naught. So let us now draw this is time scale and V naught. So when Vs is 0, this is my scale. So when Vs is 0, I have Vp plus V gamma. Vp plus V gamma. Okay. And when Vs is Vp, it goes around here. That is 2 Vp plus V gamma. Again, when it goes 0 here, this comes to here, this comes to here. Okay. And then it goes to negative, okay, minus Vp. Then this goes to up to V gamma and it comes here. This does not go to here. It's come here. This come here, and then further, if you increase, this goes here. Okay. Or like this, it is keep on moving. So now the shifting clamping happens plus Vp plus V gamma. If the source is not there, it is only Vp. Now it is Vp plus V gamma. So this is your output. This is the clamping. I hope you understand what is happening. Now battery can be anything. You can put a positive, you can put a negative, both the way. So this is the positive clamper or negative clamper? Leo, is the positive
Positive.
clamping on? Positive. Okay. It's going up. This is a positive clamping. Similarly, now we can change the sign. If I have a say battery here, I have a diode like this. I can put a battery like this, and the process is same. The things will be same. You can put a RL here. Here, V naught is there. Here, now you have to charge the capacitor, and charging will always It is already reverse bias. Positive cycle, it will be more reverse bias. Charging will happen only in this direction. So now say once it is charged, I have to again find what is the value of VC. VC will be what? VC will be, you have to write equation minus Vs plus V gamma plus Vc equals to 0. So Vc will be Vs minus V gamma, that is peak value, if you take peak value Vp minus V gamma. Okay, so this will charge in this direction and this value will be Vp minus V gamma. And once this happens, this will be completely out of circuit. And now you can write equation for your voltage. Okay, so now my Vs, this one, minus Vp minus V gamma, okay, plus V naught equals to 0. So V naught will be Vs minus Vp minus V gamma, that is Vs minus Vp plus V gamma. So my V naught will be what? V naught will be Vs minus Vp plus V gamma. And we'll draw the clapping. We'll draw here.
Sir, Vs plus Vp minus V gamma.
Hmm?
Vs plus Vp minus V gamma.
This plus Vs plus minus Vs minus V gamma. Correct. Now let us draw the output and tell me how it will come. This is Vs. V naught. Okay. Tell me what will happen when Vs 0. This is Vp. This is Vp minus gamma minus V gamma, and it goes here. This is 2 Vp minus V gamma. Again, it comes to 0. It comes to here. Okay, tell me what happened after that. And when it's minus Vp, it just goes up to minus V gamma up to here. This level is V gamma. So it just goes up to, sorry, just goes up to here. And then when it comes to 0, okay, it comes back to here. So as you plots little bit higher, plot little broad, so the plots symmetric. Okay. Is that correct or some problem is there? If your Vs 0, then it's Vp minus gamma. Okay. And when it's Vp, 2Vp minus gamma, when it's minus Vp minus gamma minus V gamma minus V gamma. Okay. And it's correct. So, but it is shifting is not happening now. Tell me what is the mistake? how does the level shift is level is shifted? So is that equation is correct what we have written? Let me check. Give me 1 minute. I'll check the. So we have done, this is a positive clamper. Okay, it's looking correct only. It's going here. Tell me what the mistakes we are doing. Tell me, please. This is VP minus V gamma. This is correct. Okay. So let me draw it again. So my V naught will be here. If I write minus Vs minus VP minus V gamma plus V naught equals to 0. So V naught will be what? This is minus Vs plus Vs plus Vp minus V gamma. Okay. So when it is 0, this Vp minus gamma. So this is Vp. So this is Vp here, somewhat less than this one, Vp minus gamma. Okay, and then when is Vp to 2 Vp minus gamma. So this is 2 Vp minus gamma here, correct? Minus V gamma. And then when it again comes here, 0, it comes here, it's correct here, up to here it is correct. Okay, now what happened, tell me? When you put minus Vp, okay, so this minus Vp, it should go to the minus V gamma. Minus V gamma till this point, it should go to here, somewhat here. Okay, correct only. 0 Vp minus gamma, that's correct only. That's correct only. Okay, now tell me what is the level? Earlier it is 0, so it is 0 level. Now tell me what is the level? Level is now what? Vp minus gamma. Vp minus V gamma. Now this difference should be 2 Vp. So this is 2 Vp minus V gamma. 2 Vp minus V gamma. And this is here minus Vp. Okay. So this is VP, here Vp. So the difference between these two, how much is there? This difference should be 2 Vp. Is this 2 Vp? No reply. Is the difference is 2 Vp, yes or no? Or is coming more? So that means this should be somewhere here. But y should come positive, na? So if it's coming here, this should come here, somewhere here, V gamma. So 2 Vp minus V gamma, it should come here. This peak to peak value should not change. Peak to peak value should not change. So tell me what is the mistakes happening? Why it is coming negative here? It should come positive here, na?
Sir, initially you've taken minus Vs plus Vc plus V gamma.
So
And
so here this is so if you write here minus, this is charging happening like this. This is minus minus Vp plus V gamma minus Vp plus V gamma plus Vc equals to 0. So Vc will become Vp minus V gamma. That is correct. Okay, that is correct. Now here we are doing mistake. This mistake you're doing now, you're not telling. So when I write minus Vs plus V gamma, sorry, plus minus Vs. If I'm going like this, minus Vs, this minus, correct only, minus Vc. Vc is Vp minus V gamma, and then it will plus V naught. Plus V naught is 0. Okay, so V naught is Vs plus Vp minus V gamma. Some mistake is happening. Some minus mistake is happening that I'm not able to correct here. Tell me what is it what you are saying? Tell me. Some student was saying some suggestion.
here, but sign is opposite, na? Here you are doing plus. Here you're doing minus. How is that?
Here.
No, the first one.
Here. If this is the plus, this is the minus. Okay. So how let I let minus Vs minus Vp, because current is flowing like this.
Yes.
And this plus Vr and the plus Vc. This is Vp minus V gamma. This is correct.
Vc is also plus how?
Vc is this Vc is coming here like this, and it will charge from here to here, na? So Vc is equal to Vp minus V gamma. Obviously, earlier it was Vp plus V gamma. Now it should be Vp minus V gamma. That this charging is same. Okay, but when I'm writing this thing, some mistake is coming here. This should come V gamma, because V gamma 2 Vp minus V gamma plus V gamma. This peak to peak value should be 2 Vp only. So what is the mistake is happening? I don't understand. So my battery is plus this is the battery. Earlier I was positive. Okay. So earlier what is the what we are getting? Tell me what is the what we are getting earlier? Earlier it was like this. First case. So first case, if it is there, they should come down only. They should come down only. Okay. My problem is only I want to say this difference should be this here to here. The difference should be 2 Vp. So this is minus V gamma. So 2 Vp minus V gamma minus V gamma equals to 0. 2 Vp minus V gamma. This is plus V gamma equals to 0. This Vp is correct only. It's correct only. Correct only. No issue. And earlier, when it was 2 Vp plus V gamma, then it was slightly above the Vp. Okay, that is also 2 Vp. Okay, we'll do one more question, then it will be clear. Say we'll do negative clampers now. Say negative clampers. Say we have Vs. Vs is equal to Vp sine omega t. This is my capacitor, and say here I have a diode, and I am making positive bias here, and this is RL. And now let us see what happens. Some portion should come above V gamma. V gamma. Now charging will happen only in this direction. So this will come to plus Vc. Okay, and this will become short circuit. V gamma. So let us find the Vc. So now I will write charging happening in this direction. So minus Vs. I'm taking the peak value minus Vp. plus VC plus V gamma equals to 0. So VC will become VP minus V gamma. VP minus V gamma. Okay, these things. And now once it is charged, this will become open, and now you can come here plus minus V naught. So this become minus Vs plus Vp minus V gamma and plus V naught equals to 0. So V naught will comes Vs minus Vp minus V gamma, that is Vs minus Vp plus V gamma. Okay. Now say you have a battery, you have this thing. Sine wave here. Now plot, tell me what is the answer is coming about plotting. So this is my Vs and this is my V naught. If it is 0, okay, then I am somewhere here. Vp minus Vp plus gamma minus Vp plus V gamma. And when it is 0, when it is Vp, I am at V gamma here. This V gamma. Okay. So earlier when this V gamma was not there, I was here. At Vp, I was 0 and this was minus Vp. Okay, you remember? When this battery was not there, this was minus Vp and here at 0. Okay, again to 0, you come back here and when is a minus Vp, then you go to minus 2 Vp plus gamma. So this will come here. It will come here. Again up to here. So this is your minus 2 Vp plus V gamma. Now difference you see, V gamma minus 2 Vp plus V gamma. So V gamma minus minus plus 2 Vp and this is come minus V gamma cancels out. So difference is your 2 Vp. The difference should remain same, only should be clamping should be happen. So this is correct. Oh, this come like this. So please draw symmetrically. Here it is, sometimes it's not possible to draw. Now the last case is there, negative clamper with a negative bias. Do it now. Tell me how it will come. So some you're applying positively, it will go a little bit up because of negative clamping. It is like here, and now because plus is there, it will go up. Now put a minus, you put, it will come down. Okay, do the last case. So the last case is what? Last case here, instead of this one, I'll put here minus V gamma RL. Okay, draw it and tell me the answer. Now you can do it yourself. And the diode is like this. Tell me what is VC now. What is the value of VC? Tell me.
Vp plus V gamma.
So again, it will charge in this direction. Okay, so minus Vs minus Vc minus V gamma equals to 0. So Vc will be Vp plus V gamma. Vp plus V gamma. And after that, it will be close. So your minus Vs plus Vp plus V gamma plus V naught equals to 0. So V naught will be Vs minus Vp plus V gamma. Okay. Now it will go more down. So when it is 0, you are at minus Vp plus V gamma. Correct? This is also minus Vp minus V gamma, minus Vp minus V gamma. When it is Vp, you have to V gamma. This is V gamma, where you are here. Again, you are here. Okay. And when you are here, V minus Vp is minus Vp plus 2 gamma here. This level become this level is minus 2 Vp minus V gamma. So it will negative battery, it came a little bit more down. That's it. So this was your clamping. We'll do some couple of problems more later. Okay. Now let me start a new topic. Now Zener diode.
एक्सक्यूज मी सर, एक बार प्लीज आप इसका प्लॉट बता दीजिए कैसे किया.
इसका ना
यस सर.
अगर ये 0 है तो ये क्या आएगा? V नॉट क्या आएगा? माइनस Vp माइनस V गामा. दैट इज माइनस Vp प्लस V गामा. ये वाला Vp से भी नीचे चला जाएगा, माइनस Vp से भी. ठीक है. अब ये जब Vp है तो Vp भी कैंसिल, माइनस V गामा, बिकॉज द जीरो स्केल इज दिस वन. दिस इज बेसिकली माइनस V गामा. Okay. And when this is again this is a minus Vp, so minus Vp minus Vp minus V gamma, that is minus 2 Vp minus V gamma, this one. Now if you say the peak to peak difference is how much? Peak to peak difference is how much? So this is minus V gamma minus 2 Vp minus V gamma, minus V gamma minus plus 2 Vp, and this is plus V gamma cancels out. So peak to peak value is 2 Vp. तो लेवल only should happen shifting. अगर ये बैटरी नहीं है तो ये हमारा कहाँ आ रहा है? ये हमारा माइनस Vp से यहाँ तक आएगा. अभी माइनस बैटरी लग गया है तो ये नीचे आ जाएगा. अगर ये पॉजिटिव बैटरी लगी है तो ये क्या हो जाएगा? ये थोड़ा सा ये थोड़ा माइनस V प्लस V गामा आएगा और ये थोड़ा सा ऊपर हो जाएगा. बस शिफ्टिंग हो रहा है और क्या. क्लियर और शुड एक्सप्लेन अगेन?
सर इट्स क्लियर.
So now the next topic is your Zener diode. Okay. What is Zener diode? So you have, this is the symbol of Zener diode. Now Zener diode is what? In Zener diode, it works in the reverse bias. Okay, it operates in reverse bias. Okay. Now Zener diode is slightly different compared to the normal diode because the doping levels are high. Okay, here doping levels are high. No, compared to normal p junction, doping levels are high. Now we know the IV characteristics of a diode. This is ID and this is the VD. So in the forward direction, my current changes like this. Okay, and the reverse direction, my current goes in the breakdown region. Now in Zener diode, breakdown happens at the particular voltage which is called Zener breakdown voltage. Okay, the breakdown happens at particular voltage. Now if I apply here, the voltage across is there VZ or greater than VZ, then what will happen? This diode will come in the breakdown condition, and the voltage around this will become fixed, but current can go. So current can go from how much? Current can go from IZ minimum. IZ minimum is the what the value? IZ minimum is the value when here the voltage is exactly VZ. The current current will start flowing, and the value will be minimum value. The when minimum current is flowing in through the diode, the voltage across diode will be VZ. Now, if we further increase the voltage, reverse bias voltage, here voltage will remain fixed, here voltage will not change, but current is the passing current will start keep on increasing, and it can go maximum IZ max. So what is the IZ max? IZ max is the value of Zener current which we can allow, maximum current which we can allow through the Zener. If the current become more than this, what become, this Zener diode will get damaged. So basically what I'm trying to say here, that this is diode works in the reverse bias region, and in order to it to conduct means here the current is, initially current is what, very small current, reverse saturation current flowing. Now that is not conducting, that is like open circuit. But if I want that it should conduct, it should flow more current, then you have to apply minimum voltage VZ. When the voltage across this is the VZ, it will start conducting, current will start flowing like this, opposite direction, current will flow like this. Okay. And now if you still keep on increasing voltage across the diode, the voltage drop will not change. Voltage drop will, if you change the battery, if you increase the voltage, so here voltage drop will not change. But because the now it is working in the breakdown region, and breakdown region it becomes like a conducting part. So if you increase the voltage drop will not change. Whatever voltage drop is, it will remain the fixed. But now what will happen? Current will keep on increasing. So current will keep on increasing, and but you cannot allow the current more than IZ max, because this diode will become damaged. Now the question is, what is the difference between an avalanche breakdown and what is the between a Zener breakdown? Okay, so Zener breakdown, what happens, because the doping levels are high, and I told you, whenever the doping levels become very high, the width of PN junction becomes small. Okay, whenever doping levels are very high, there is a depletion region in the PN junction, that the junction becomes very thin. And now when junction is very become thin in the micrometer length, the electric field inside the junction become very high, because there is a voltage drop across the PN junction, and now the thickness becomes smaller. So electric field is what? Electric field is your voltage divided by length, VD. So you have a PN junction, and you're applying reverse bias. Okay, now because whenever doping becomes high, this PN junctions become very thinner, and when this becomes thinner, you're applying some voltage drop here. This difference distance is very small. So here inside the junction region, the electric field is very high. Now when the electric field is high, this electric field is sufficient to break the bond. Avalanche breakdown happens when breakdown का मतलब है, there is a more and more number of charge carriers. So this electric field become very high, that what it causes? It causes the breaks to bond, because you have a silicon bond. Okay, here you have a silicon bonds. And when this voltage is very high and this electric field is very high, this electric field itself is sufficient to make these this bond electron free. So when more this bond breaks, you have more and more number of charge carriers, and current start increasing, and it's like a becoming conducting region. Okay, so this is the Zener breakdown. Zener breakdown generally is less compared to the avalanche breakdown. Avalanche breakdown will suppose happening here, Zener will happen here. Now we can design a diodes which have a different VZs. Okay, say 5 volt, 7 volt, 3 volt, that we can design. Okay, our depending on our need. Now here the bond breaks because of electric field. This is the electric field assisted breakdown. Okay, what is Zener breakdown? Zener breakdown is field assisted breakdown. Field assisted breakdown. Okay, while your avalanche breakdown is impact ionization. Impact ionization means the field is not sufficient to break the bound. Okay, because it is slightly the width is high. The electric field itself is not sufficient to break this bond. But how does the now break bond breaks? Now, if you keep on increasing the reverse bias voltage, there are some free electron in the junction. Okay, these free electron will collide with this bond, because when you're applying voltage, you are giving more energy to the electrons, and the electron have a more kinetic energy, and they will they will hit this bond, and one electron, say, when it's colliding with one bond, it is creating one more electron free. Now these two electron will collide with two bonds, and they will make four electron free, and now this is the cascade chain process will start. Okay, so this is field assisted and avalanche breakdown. Avalanche breakdown is your impact due to impact ionization. This is because of impact ionization. So both the mechanism is different. That's why we call one is avalanche breakdown, one is a Zener breakdown. Okay, that is the difference. Now, how does we work in the circuit? So how to deal this kind of Zener diode in the circuit? So let us understand. So whenever you have a diode is reverse bias, and the voltage across the open circuit voltage is greater than or equal to Vz, you can replace this by a battery. Now you see, I am replacing negative battery with positive battery, because now Vz is like this. So I can replace this by a fixed voltage battery in the reverse bias. This is in the reverse bias when open circuit voltage across Zener diode is greater than equal to Vz. Okay. Now, if it is a reverse bias, but open circuit voltage across the diode, open circuit voltage, the Zener diode working in the reverse bias itself, open circuit voltage is less than Vz, then you have to treat it as like a open circuit, because if the voltage is less than Vz, the current is very small, and that we can treat as like a open circuit. So you have to keep it open. This is the second thing. And now forward bias, it is the same thing. Forward bias, it's a behavior like a regular diode. Okay, this is a reverse bias. In forward bias, Zener diode is a diode works like an ordinary diode. ऑर्डिनरी डायोड का मतलब क्या होता है? अगर आइडियल डायोड है तो शॉर्ट सर्किट, अगर सिलिकॉन डायोड है तो यू रिक्वायर 0.7 वोल्ट and it will become battery. Okay, if silicon diode hai and the voltage is less than 0.7, then it is open. So you know how to ordinary diodes work. You have to treat in forward bias like a ordinary diode. So that things you have to keep in mind. And now we can solve. Okay. आप बोल भी नहीं रहे हो कि दिख नहीं रहा है. Okay, so let us understand now how does Zener works. Shall I erase this one? Any question? Sally,
Yes, sir.
any doubt?
No, sir.
Okay. So what is the use of Zener diode? So Zener diode is worked as a voltage regulator. Okay, Zener diode as voltage regulator. Because the voltage across the Zener diode is constant, so you can, if you take a load resistance and you connect across the Zener diode, you will always get a fixed voltage. That's why it is a work as a voltage regulator circuit. Now, what is the voltage, simplest voltage regulator circuit for Zener diode is, you have, just give me 1 minute. So here I have a battery. Okay, say V source or V input, and here you have a series resistance RS. Here you have a Zener diode, and here this is the voltage regulator circuit, and this is a load resistance RL. Okay. Now this voltage Zener diode has some parameter. Okay, VZ and IZ max. These parameter we should know. Okay, so VZ, so that is what is VZ for Zener diode and what is IZ max, maximum can flow. That means we should know the what is the PZ max of Zener diode, because PZ max is IZ max into VZ. Okay, PZ max, how much maximum power can be consumed is safe for the Zener diode, that is given by VZ into IZ max. So these are the performance parameters. Okay, these are called performance parameters. Performance parameters. Now, if I want the voltage across the Zener diode should be constant, so here a minimum value is required. Suppose here if I want 5 volt, so in order to 5 volt should come here, that depends on this voltage, how much voltage is there. This voltage will decide whether 5 volt is coming or not coming, depending on this resistance. So there this, so these resistors and this, so for given VZ, okay, and given Vs, this there should be some values of RS RL. Okay, similarly for given VZ and given RS RL, there should be some voltage range of this Vs, because Vs should be minimums to make it operate. And but beyond V input should not go beyond a limit. If Vs get increases, that here the voltage drop will increase and current will can keep on increase. So this diode can burn. So these are all the things we have to keep in mind. Now you see, if I'm applying some Vs, some current will flow here I. Okay, this I current will divide here. Some current will go in Zener diode and some current will go in the load. And this is your V load. Now, first of all, let me show you one question, then you will understand. Say I have a circuit where this Vs is 10 volt. Say this is 10 volt. Say this is 40 ohm. Okay, say this is 40 ohm. And Vz is say 6 volt. And RL is also given 100 ohm. Tell me whether this diode is in conducting state or not. Yes or no? Whether this diode is working or not. Find the voltage, open circuit voltage across the Zener diode. What is the open circuit voltage across the Zener diode? Tell me. So when I make it open, so voltage will be measured by this load resistance. So that's why this load resistance is also important. If it is become lower, this voltage become lower. If this is higher, this become higher. Okay. So now what is the current is flowing in the circuit? So current in the circuit is 10 volt divided by 140. That is current, and the voltage drop across the linear will be 100. How much coming? Tell me. 100 divided by 14. What is the value? Tell me. What is the value? Open circuit voltage. This is I. This is I and open circuit voltage. Open circuit voltage is equal to 100 divided by 14. How much will come? Tell me.
7.14.
7.1. Okay. So this voltage is greater than 6 volt. Yes or no? Zener voltage. That means the open circuit voltage is higher than the Zener voltage. So this you can make it on. Now this is on. So you can replace it by a battery. Now this become 6 volt. Okay. Now you can find what is the current I, what is the current IZ, what is the current IL, and what is the VL. Okay. So find voltage drop here. Say this is IR. Find VR. Okay. VZ you know. Find VR, VL, IR, IZ, and IL. Now VR is what? Now in this case, if this is the on, okay, now this is open, this you don't require. Once you know this is conducting, now this calculation you don't require. Now this is 6 volt, this is 10 volt, this is 6 volt, so remaining 4 volt will come here. Always focus on this loop. This is 10, this is 6, so here it will be 4. Now the current IR flowing in the resistance, IR will become how much? 4 volt divided by 40 ohm, that is 1 by 10, that is 0.1 ampere, that is 100 milliampere. Okay. Now once this is a connecting, this voltage and the load voltage will become fixed. So now V load will become how much? V load will become also equal to VZ equal to 6 volt. So I load will become, current will be 6 divided by 100, that is 0.06 ampere, that is 60 milliampere. And now this I, if you apply KVL here, IZ is what? IZ is your I, this IR minus IL. So this is your 100 milliampere, this is your 60 milliampere. So IZ become 40 milliampere. This is the solution of this circuit. Let me give you one more problem. Karishma, is it clear?
Yes, sir.
Okay. तो अभी ये क्वेश्चन है, and now we'll see how there are many, how can we can change, we can form different kind of questions in the same simple circuit. Okay. And how does you play with this R and this and with this battery? So say I have a circuit, same circuit. Now I have here say 16-volt battery. Okay, this is your 1 kilo ohm resistor. Here a Zener diode. Okay, whose value is 10 volt, and PZ max is given 30 millivolt. Okay, PZ max is given 30 millivolt. So you can find the IZ max also. And here is a 1.2 kilo ohm. Okay, solve this circuit. Tell me whether this circuit is on or off. Zener diode is regulating or not regulating. Tell me the value. What is V open here?
सर वो 1.2 है ना, 1.2 किलो
1.2 kilo ohm hai. Tell me what is V open, VZ. So V open across Zener diode. Okay, so I am make it open. What is the value? Tell me. I. So here basically this will be equal to what? Current into this resistance. Current is how much? 16 upon 2.2 kilo ohm and 1.2 kilo ohm. What is the voltage? Tell me.
8.72.
8.72. This is less than 10 volt. That means now Zener diode will be open. It will not operate. And now you can find what is I in the circuit. I is already you have find. I is what? I, and now I will be equal to IL. Same current will flow. And I value is what? I value is your 16 upon 2.2 into 10 to the power 3. You can find, you can calculate. Okay. And now V load is how much? V load is, you can find here, I into IL into 1.2 kilo ohm. That will be V load. Okay. IZ is how much? IZ is how much? कितना है IZ? Shekhar?
0.
0. IZ is 0 because open. So no current is flowing in the Zener. Okay. So this, so now see, you require here 10 volt. You applying more than 10 volt here. Still this diode is not on. Why? Because this resistance is very small. That is here also for given circuit, given voltage, given resistance, this also should be some fixed value more than this value. So this is also should be minimum and maximum value. Okay. So now say let us change this by, I'm changing this resistance by 3 kilo ohm. And the same Zener diode. Tell me what is the calculation now? Tell me what is the calculation now? 12 volt. Now what is V open? Across Zener. Zener diode. Okay, simply you can write Zener diode. Make it open and find this one. How much is coming? 16. Now this is 1 plus 3, 4 kilo ohm into 3 kilo ohm. It is coming out 12 volt, which is greater than 10 volt. Okay. So when this happens, you find the zener is on, and once zener is on, you can say what? You can say this is can be replaced by a battery of 10 volt. Now all calculations will change. Okay. Now this is IR, this is IZ, and this is IL, BL. Okay. So you can find IR, IZ, BR, BL. Okay, बताओ कितना होगा? Now IR is how much? What is IR? Tell me. कैसे निकालेंगे IR?
16 milliampere.
So this is 16. This is 10 volt. How much? How much? How much you said? So this is 16 volt. This is 10 volt. Remaining 6 volt will come what here? So IR become how much? 6 volt divided by what?
milliampere.
6 milliampere. Okay. What is IL? IL is how much?
3.3 milliamp.
Okay, 10 volt divided by 3 kilo ohm. That is 3.3 milliampere. So IZ will become how much? 6 minus 3.3, that is 2.7 milliampere. V load is fixed to 10 volt. Okay. VR will be IR. VR is already 6 volt. We have already seen. So this circuit is solved. Okay. Now important thing is here that I told you, if I'm putting 1.2 kilo ohm, then this diode is not on. Okay, I'm putting 3 kilo ohm, this diode is on. Okay, so there may be some limit, some minimum value of this one, which diode will become open. Okay, now with this circuit, I want to find what is the minimum value of load. Okay, now you know what is the minimum value of load, the value of this one load which makes this zener diode on. Okay, so now I don't know the RL. I want to find RL minimum. Same circuit. What is RL minimum? Okay, I am keeping the voltage fixed. My V input is fixed, and now I am varying RL. Varying RL means I want the value of RL minimum and RL max. So now what is the value of RL minimum? So the value, because the voltage, if you want to make this diode on, you have to check the voltage here. That means this should have at least some value such that the voltage across the zener is at least equal to 10 volt. Then it will only be on. So you can find now V open. Okay, for RL minimum. What is the condition? For RL minimum, your V open should be equal to VZ. V open should be equal to VZ. Then only this diode will come on. So from there we can find, because this increases, voltage drop here increases. So I want some value of this one. For that, this is exactly 10 volt equal to VZ. So this will be the minimum value. If you increase this one, this voltage will increase for given circuit. Okay. Now V open will be what? V open, you know, you make it open. V open will be what? 16. This is 16 RL, R plus RL, R plus RL into RL. That is V open, and that should be equal to VZ. From here, I can find the value of RL minimum. Okay. So what is RL minimum? Tell me what is RL minimum? That will be VZ is 10 volt into R plus RL minimum. Not this RL minimum. Okay. RL minimum 16 RL minimum equal to 10 R plus RL minimum. Okay. How much coming? Tell me. This is 16 RL minimum equal to 10 R plus 10 RL minimum. So this is 6 RL minimum equal to 10 into R. So RL minimum will be 10 into R is 1 kilo ohm and 6. Okay. What is the value? Tell me. It's coming.
Sir, it's 1.67.
1.67
1.67 kilo ohm.
kilo ohm. Very good. Okay. So this is the minimum value of RL. Okay. For that, this Zener diode will become on. Okay. Now, what is the RL max value? What is the RL max value? How to find the RL max value? Okay. Let us find RL max now. Now PZ max is given to us. PZ max is 30 milliwatt. So what is the IZ max value here? Tell me what is the IZ max value here for this circuit? If this point is clear to everyone, tell me. If this point is clear to everyone, Deepak, Amardeep.
Yes, sir.
So ये क्लियर है ना कि RL मिनिमम कैसे निकालेंगे? अब RL मैक्स कैसे निकालेंगे for given circuit? Okay, for RL max, for RL max. Okay. Now I know what is PZ max is given in the question. PZ max is 30 milliwatt. Okay. And I know my VZ is 10 volt. So my IZ max is what? Tell me. IZ max will be your 10 volt, 10, what is IZ max? PZ max is equal to IZ into IZ max into VZ. Okay. This will be PZ max upon VZ. So IZ max will be PZ max is 30 millivolt. What? VZ is 10. That is cancel out. That will come 3 ampere. That is 3 milliampere. Okay. That is 3 milliampere. And now I'm finding RL max. So once I know the IZ max, now what is the use of IZ max? You know, my IR here is equal to IZ plus IL. Okay. Me. When I'm increasing RL, my IZ, this IL will decrease or increase. Kavishma, if I'm increasing RL, what will happen on the current? Load current,
So it will decrease.
it will decrease. So for if the circuit is on, so we already know minimum value, and once you are above the minimum value, your circuit is on. Now you will keep on increasing this RL. I want to find how much RL max I can increase. So when I increase this one, my IL will keep on decreasing, and my IL will keep on decreasing because this is on. That this voltage is fixed, this voltage is fixed, this voltage is fixed. That means my IR is fixed. Or if your RL greater than minimum, IR is fixed. IR will not change. Whether you change RL, this IR will not change because this is on. This fixed, this fixed, this fixed. But now still you are increasing RL. So now this I load will keep on decreasing. So this is fixed. This is decreasing. That means this will increase. But I don't want to this to go beyond IZ max. Okay. So when my IR is fixed, when what is the value of IZ max? If IL is decreasing, so the value of RL max, this will become IL minimum. So now I can find what is the value of IL minimum. IL minimum value is what? IL minimum will be IR. What is the value of IR here? 6 volt divided by 6 milliampere. 6 milliampere. And IZ max is how much? 3 milliampere. So IL minimum become 3 milliampere. Now I already know what is my VL. My VL is equal to RL max into IL minimum. The value of resistance for which the current is I minimum. Okay, I know VL is 10 volt. IL minimum is 3 milliampere. Okay, so what is the value of RL max? 3.3 kilo ohm. So for given circuit, my RL value ranges 1.6 kilo ohm to 3.3 kilo ohm. That is RL minimum. If you start, this will become on. Now you keep on increasing, this will remain on. But value when it reaches RL max, my current here become very down. So this current is fixed, so this current will increase and this will burn. So these are the limiting value when your VI is fixed. What is the value of load you can change? You can find in this manner what I told you now. Okay. Is that point clear to everyone?
Yes, sir.
Okay. So this is the first case of Jenner. I'm giving you one more question, and this is your homework. You have to tell me what is the value of RL minimum and RL max. Okay. You have to send me now after solving. So say you have here a voltage is 50 volt, 50 volt. R is again 1 kilo ohm. Zener diode is say again 10 volt. Okay. And now I am putting this here a load resistance, which is value is varying. Okay. And again say IZ max is given. Instead of PZ max, this time IZ max is given 32 milliampere. 32 milliampere. RL is varying. Okay. Find the RL minimum and RL max in order diode to conduct. Zener diode to conduct. अगर okay, अगर voltage regulation चाहिए, diode conduct चाहिए, तो what is the value of RL minimum and RL max? This is your homework, and you have to send me. Okay, so I'll stop here. Send me the homework, and then we continue tomorrow with second case. Okay, So when you find the RL minimum, RL max, when you find the RL minimum and RL max, so obviously you can find what is IL max and what is IL minimum also.
Minimum.
So these 4 parameter you have to calculate and send me. Okay, thank you.
Thank you, sir.
The value you should remember 10 volt, 32 milliampere, 1 kilo ohm, and you have to find the RL value.